Hello and welcome to the first lesson on Module 12, Completing the Square. Like I told you in the introduction, we're going to split this into two videos because there's quite a bit here. So I'm going to try and develop, notice all the learning targets. Okay, so we're going to focus on the first two in this first video. So identifying a perfect square trinomial, what is that? Find the missing term needed to create a perfect square trinomial. And we're going to use that to solve a quadratic with a linear term. Okay. In the second video, we'll solve a quadratic equation and leave the answer in simplest radical form. And we'll solve a quadratic when a is not 1. So just a couple things to review. We've graphed before. We looked at the 5 key features. And we used the graph to solve. And at the end of last week, we looked at finding square roots. We would add 6 to both sides and then divide everything by 3. You get x squared equals 49. When you introduce the square root, you get plus or minus whatever the number is. So plus or minus 7 in this case. Now, with this one, remember how with this method, b had to be 0. Well, what happens if b is not 0? Let's take a look. So x plus 3 squared equals 16. So x plus 3 squared is x plus 3 times x plus 3. And this is a picture of what that looks like when I multiply those out. X times x is x squared. 3 times x is 3x. X times 3 is 3x. And 3 times 3 is 9. So if I would rewrite that, I would have x squared plus 6x plus 9 equals 16. Okay, let's do a couple more of those. Just show you what that's looking like. And before I show you a couple more, x squared plus 6x plus 9, that's called a perfect square trinomial because it's made from something squared, a binomial squared. So x plus 3 squared made x squared plus 6x plus 9. All right, so let's try another one. X minus 7 squared is going to give me x squared minus 14x plus 49. That x squared minus 14x plus 49 is a perfect square trinomial. One more time. And again, I'm showing you the picture because that's going to come into play here in a little bit. So x plus 8 times x plus 8 is x squared plus 16x, 8x plus 8x plus 64. So x squared plus 16x plus 64 is a perfect square trinomial. Okay, so let's go the other way. Can you change these to look similar to the previous problems? Okay, so x squared plus 12x plus 36. Notice I'm not worried about the 16 right now. Is there two numbers that multiply to 36 and add to 12? Well, it would be 6 and 6. I can write it as x plus 6 squared. How about the next one? Is there a number that multiplies to 25 and adds to negative 10? It'd be n minus 5, or n minus 5 squared. Okay, now why are we doing all that? Well, can you solve these types of equations? Well, let's look at it. Let's look at the first one. X plus 6, the quantity squared. I want to take the square root of both sides. When I do that, the squared and the square root cancel, and I'm left with x plus 6. And then on the other side, the square root of 16, remember the plus or minus, 4. Now, we introduce the square root, so that's why it's plus or minus. So I'm going to subtract 6 from both sides after I set up my two equations. Because it says x plus 6 equals 4, and x plus 6 equals negative 4. So it equals two different things. So we need to set up two different equations. See how I did that? X plus 6 equals plus or minus 4 splits into two equations. X plus 6 equals positive 4, and x plus 6 equals negative 4. And then we solve both of those by subtracting 6. So x equals negative 2, and negative 4 minus 6 is negative 10. So those are the two solutions to that problem. How about the next one? We can take the square root of both sides. The square root and squared cancel. I'm left with n minus 5 equals plus or minus 9. I want to make my two equations. N minus 5 doesn't change. It's not n minus 5 and then n plus 5. It's n minus 5 equals 9, and n minus 5 equals negative 9. Add 5, I get 14. Add 5, and I get negative 4. And so my two solutions there are 14 and negative 4. Okay, well, they're not always going to be nice and set up like these two were. These were both set up to be perfect square trinomials. What happens if they're not? Well, go back to the learning targets. We're going to find that missing term that creates a perfect square trinomial. So here's an example. This is not a perfect square trinomial because negative 5, there's not two numbers that are the same that multiply to negative 5 and add to 8. It just doesn't work. So what I'm going to do is I'm going to move the 5 to the other side. I'm going to add it to get it out of the way. and that's going to create a space here, a missing term. Now I'm going to be adding that to the left-hand side, which means I also have to add that same number to the right-hand side. Okay, that's a big step. You got to remember to do that. Whatever you add to one side, you got to add to the other. Well, here's my blank right now. Here's my picture. The picture can help me here. I need two numbers that are going to give me, when I add them together, are going to give me 8x. So these two rectangles, lighter colored rectangles, have to add to give me 8x, and they have to be the same. They're the same size. Well, what plus what gives me 8? It would be 4 and 4, right? Well, where did those numbers come from? Well, these terms up here need to be 4 and 4. Well, then if I multiply 4 times 4, I get that last little box there, the 16. And that 16 is what goes in the blank. Now, my new constant, I can find it quickly. I don't have to use this picture each time. The b value, in this case, was 8. Divide that by 2. That's the 4. And then square it. That tells me what number goes on that line. And notice I add 16 to both sides. Now I have a perfect square trinomial. I can write that as x plus 4 times x plus 4, or x plus 4 squared. And then 33 plus 16 is 49. Now I have a problem that I can solve using square roots. So I'm going to square root both sides. I get x plus 4 equals 7 and negative 7. And that's when I'm going to make my two equations. X plus 4 equals 7 and x plus 4 equals negative 7. Subtract 4, I get 3. Subtract 4 and I get negative 11. I do one more of those in this video, just so you can see it happen again. I'm not going to use the picture this time to show you what I'm expecting you to be able to do. So this is not a perfect square trinomial. I need to move the 30 out of the way. So I'm going to subtract it from both sides. Leaves me a blank. What number goes in the blank? Well, I take the b value, which is negative 14, divide it by 2, so that's negative 7, and then square it. Negative 7 times negative 7 is positive 49. And I add that to both sides. Now I can rewrite that as n minus 7 squared, right? Negative 7 times negative 7 was 49. Negative 7 plus negative 7 is negative 14. Okay, so it's n minus 7 squared. 32 plus 49 is 81. Square root of both sides, I get n minus 7 equals plus or minus 9. N minus 7 equals 9, and n equals 7, and n minus 7 equals negative 9. Add 7, I get 16, and I get negative 2. And those are my two solutions. So that's the end of the first part of lesson 1. If that was confusing, please go back and watch those last two examples again. That's what I'm going to be expecting you to do. I'm not saying it's going to be easy, but it is something that you're going to have to do. You're going to have to follow that process. Okay, try to understand why I'm doing each thing as you're watching that. So let's stay tuned for part 2.